Hello boys and girls, and this is the teaching video for fractions week 2, and this week we're on equivalent fractions 1. So what I want you to do is to go and get your math sheets out of your home learning file, bring a pencil and some paper. Pause this while you go to get those things. Okay, you're back now. This is just exactly what you would have been doing in school with your teacher. On the screen we would have been doing the same things together. The only difference is I have to guess what you're saying, but you're going to try a few things on sheets of paper and on your sheets as well, and pause it whenever you need to. Okay, so let's begin. We're on number 1. The first question says shade the bar models to represent equivalent fractions. Before we begin, we need to know what equivalent fractions are. There is a big long word, equivalent, and it really just means the same as. Say for example you had a test, your spelling test out of 10, and you got 5 out of 10. Okay? You could change that into an equivalent fraction, because you could say, oh, I got half of them right. So look, those are different numbers, but they mean the same thing. And that's what equivalent fractions are. So let's look at A. It said shade the bar models to represent equivalent fractions. So these are like chocolate bars. So look over here, we have to shade in a half first of all. So let's shade a half in. And down below, the exact same bar of chocolate is sitting, but it's been divided into 6. So 6 people will get it this time. And the equivalent fraction for a half is 3/6. And you can see that very clearly there. Down the next one, B. And you should be doing this along with me. So make sure you've got your pencil for doing shading. And it's better to hatch than colour because it's faster and just keeps it as neat. And you can see everything anyway. So B. Here we have half. So I have to shade in half. And to make it equal, then we have to shade the next one, which this time has been divided into 10 things, and that's tenths. And to make it the same as a half, 5 out of 10 is just what I've said, which is 5 tenths. So the next one asks you to shade in 4/5 this time. So the chocolate bar has been divided into 5, and we have to shade 4 of them in, so 4/5. And what would it be the same as? Well, let's look, it's 8 tenths. So this one's been divided into 10, and if you look down here, they are exactly the same. You get 8 tenths every time you get 4/5. They are exactly the same. Down to D, and this time the chocolate bar has been shaded into, or been split into 6 parts. So we've been asked to shade in 8/6. So there we are, 8 of them, 8 little chunks, and that's 8/6. And if I look over here, we have to shade in the exact same equivalent fraction, which is 3/4. So you can see there, they are exactly the same. So we know that 6/8 is just the same as 3/4. And if I said to you, you're going to get 6/8 of the chocolate bar, and your friend is going to get 3/4 of the chocolate bar, that's fair because it is the same. They have different numbers, but they mean the same thing. Number 2. A fraction wall is a very handy way of showing you equivalent fractions. So let's begin at part A, half. If we put a little line where the half ends, we are going to figure out how many quarters there are. And if you put a line down onto the quarters, we can actually see there a half is the same as how many quarters? Yes, 2/4. Let's go down to B. Now this time again, we're going for the half. And we want to see how many eighths it is this time. So we go all the way down to eighths. And again, it stops exactly at the same place. And we've got 1, 2, 3, 4 eighths. So that means a half is the same as 4 eighths. It's also the same as 2/4. Now here we're going for 2/4, and we'll just get rid of some of these lines so we can start again. So we are on C. We're looking for 2/4. So let's put a line where 2/4 ends. And it's the same as 4 somethings. Well, let's just check. 1, 2, 3, 4. Yes, it's the same as 4/8. So there we are. Part D. Now we're on 2/8. So let's put a line at the end of 2/8. And it's going to be the same as how many quarters? Well, just move it up to the quarters. And yes, it's exactly the same as 1/4. Now, I'm going to ask you to look for 3/4 this time and draw a little line. And just get rid of my lines. Draw a little line where you see 3/4 stopping. Have you done it? Yes, there it is. And we want to know how many eighths. So if we go down to the eighths line, you draw where the eighths will be. Count them now. How many eighths have you got there? Yes, 6/8. The last one then is 2 halves, and anything that's the same number in the top as the bottom means it's a whole one. So 2 halves means you've got the whole lot of it. So let's go for 2 halves, and there it is. It's finished. The whole bar of chocolate is finished, and it is the same as how many quarters? Yes, 4 quarters is the same as 2 halves, and then all the same numbers for 8 as well. So we got 8/8. 1, 2, 3, 4, 5, 6, 7, 8. 8/8 means the whole chocolate bar. So they're all equivalent. All those are equivalent. They're exactly the same. So if I said to you, you're getting 8/8 of the chocolate bar, you're getting the whole thing. 4/4 of the chocolate bar, you're getting the whole thing. And 2 halves, you're getting the whole thing. So they mean the same thing. That's equivalent fractions. This time we have been given in number 3 the fractions wall, which is blank except for one number, and it tells us that's a whole one. So imagine that's the whole bar of chocolate at the top. So it says label the fractions. Well, let's just see how many times this has been split up. We've been split up to 1 part, 2 parts, and they're all equal. Very important that they're all equal in fractions. So we've got 3 of them. That means each one is a third. 1/3. So that makes the whole thing. The next one, it's been split into 1, 2, 3, 4, 5, 6. And did you notice when I split it into 3, I put the 3 in the bottom? Now I've split it into 6, I put the 6 in the bottom every time, because there are 6 parts and each one is 1/6. So that's the next row labelled, 1/6. And again, that means the same. 3/3 is the same as 6/6 is the same as 1. Let's look and count how many on the bottom. 1, 2, 3, 4, 5, 6, 7, 8, 9. That has been split into 9 pieces. So each one is going to be labelled with a 9 in the bottom. And that's what we call the denominator. The denominator is a bottom number. And what goes on top? You write it? Yes, 1/9. Each part is 1/9. And just at this point, I want to tell you that some children who are confused about fractions think the bigger the number in the bottom, the bigger the fraction. But when you think about it, the bigger a number in the bottom means the smaller the fraction, because you're going to have to feed 9 people with that bar of chocolate with a 1/9, or the bar of chocolate split into 9, whereas you're only going to have to split the bar of chocolate into 3 if you give them thirds. So they get a smaller bit if you get a 1/9. So what if it was split into 20 pieces? You'd be feeding 20 people. And some people think, oh, that's a big number because it's got 20 in the bottom. No, it means it's small because it's been split into 20 little bits. So you only get a tiny little bit of chocolate. So let's look now at part B. Use the fraction wall to complete the equivalent fractions. Now a third. Let's go and find 1/3. You put a line there. Now if we go down, we want to find out how many 6. So draw it down. How many 6 can you see there? Yes, 2 6. And draw it further down. We want to see how many, and we know it's going to be something with 3. So let's just check 3/9. And there it is. Let's look over here. Now we have got nothing here and nothing here, so we have to rely on this one. So we need to go to 6/9. 1, 2, 3, 4, 5, 6/9 is there. That's where it finishes. And it has to match up with 4 something. So let's just check 4 of these. What are they? 6ths, yes. And it also has to match up with something thirds. How many thirds? Well, let's move the line up on, because this is equivalent again. How many thirds can you see? Yes, 2. And on to our final one here. Our answer is 1. Well, that means that's the whole one here, and that's where it would end. So this is nice and easy. Remember what we said the last time? It's going to be the full 9/9. It's going to be the full 6/6, and it's going to be the full 3/3. So we always get the same number on the numerator, that's the top number, as we do on the denominator when you've got one whole one. Now we've got a fraction wall again, and our question this time is asking us to decide whether a statement is true or false. And the statement is half is equivalent or equal to 3/6. So let's put a line down and see if it matches 3/6. Let's go down to the 6, and there it matches it perfectly. That means a half is exactly the same as 3/6. So what do we write? Tick it. True. Part 4 continued, 4B. 2/3 is the same as 3/4. Well, all you have to do is go to 2/3 and go down to see if 3/4 matches. And indeed 3/4 does not match because it's over here. So that must be false. So you continue on to the end of number 4F. And it says, ask a partner to say whether it's true or false, and you're going to write some of your own statements. So you press pause and finish number 4, and then we'll be ready to join up again on number 5. So you pause it now. Number 5 is one where you really have to think, because we're going to find out, are these statements always, sometimes, or never true? Okay, so we're going to read the question first of all. It says, draw a diagram to support your answer. So this little box here is going to help me to draw something. I have some space to draw something. Now, this is our statement. We're going to read this carefully. The greater the numerator, that means the top number, the greater the fraction. Okay, so let's do a little diagram just to demonstrate what we could find out. So it says draw a diagram. So let's try something with a biggish numerator. Now that's, remember, the top number. So let's have a bar of chocolate and we'll divide it into, let's say, 5 pieces. And here's another one, exactly the same, and I'm going to divide it into 5 pieces as well. So let's shade in 4/5 of it. Okay, so we're going to say that one is 4/5, and then we're going to shade in just 1/5 here. Now let's see if our statement is true, and I'm just going to highlight what we think. So it says, the greater the numerator, the greater the fraction. Now the greater, I'm just going to highlight the numerator here. There's the numerators highlighted. The greater the fraction, and indeed in this case this is true because the bigger number is on the top, and it definitely is the bigger fraction. So let's try another one though, because we need to find out if this really is true. So let's look at another bar of chocolate, and we'll divide this into 5ths again. 1, 2, 3, 4, 5, and we'll just divide this one in half. So we're going to shade 2/5 of this time, and we're going to shade a half. Now look what happens this time. This one is 2/5 and this one is a half, and it looks as if it's going to be a 1 again on the top, just the same as we had. Now this time it looks as if the bigger numerator, that's the 2 here, that's the 2, it's bigger than that numerator, but it's a smaller fraction. So the greater the numerator, the greater the fraction is not always true. So which one would we circle? Always, sometimes, or never. Well, it was true this time in this case, but it wasn't true in this case. So we have to circle sometimes true. And that's tricky. So just have a little pause if you don't understand that and listen to this again. Number 5, let's look at the statement on this one. Fractions equivalent to 1/2 have even numerators. Remember, a numerator is on the top, denominator in the bottom. So this is trying to tell us they always have even numerators if they are the same as a half. So let's draw a little bar of chocolate, and I'll divide it in half. I'm going to draw another bar of chocolate, and I'm going to divide it in half again, and this time I'm going to divide it in quarters. Now remember, equivalent, we have to shade in the equivalent. Shade in the equivalent, shade in the equivalent. Now remember, we're looking at the numerator again. That is a half, and this is the same as a half, it's 2/4. And what does our statement say? Fractions equivalent to 1/2 have even numerators. Well, let's look at our numerator. What is the numerator? It's 1, and this numerator is 2. What can we say then about this statement? Is it true, always, sometimes, or never? Well, in this case, look, it is odd. So it can't be correct. So that's, but in this case, it's even. So it is correct there. So we can say this statement is sometimes true. This one, it was true here, but it wasn't true here. And if you don't understand this, pause again.